Hello, in this video I'm going to talk about how to use the quadratic formula. In general, we know that a quadratic equation takes the form of ax squared plus bx plus c equals 0, and we know that the quadratic formula is minus b plus minus root b squared minus 4ac, and actually what's under the square root symbol here is called the discriminant. And it's incredibly useful in that it offers us valuable information about our equation. For example, as an aside, if the discriminant is negative, then we know that our equation is going to have no real values. But I'll save that for another video. In carrying on, we know that the quadratic formula is negative b plus minus the root of b squared minus 4ac, which is the discriminant over 2a. That's the quadratic formula. And really it's when using the quadratic formula, it's as simple as just plugging in the relevant values, and by that I mean, so the coefficient of the x squared term is a, that's b, right? A, that's b, and that's c. Our constant is c. And so you're just going to plug in the value for a, where it's negative 4 times a, or in 2 times a, and or for example the coefficient of the x term is b, so it's going to be negative that term, minus, so negative b plus minus, and then of course b squared, and on. But to offer some more lucidity as to what that all means, the best thing to do is just to jump in and work on an example. So to start, say we're given x squared plus 3x plus 1, all that equals naught, right, equals 0, and so a in this case is going to be 1. There's a 1 in front of, as a coefficient of this x squared term, there's a 1 in front here, it's implicit, so it's going to be 1. B is going to be 3, and our constant c is going to be 1. Whoops. Right, so we just plug that into our formula. So minus b, so it's going to be a negative 3 plus minus root of b squared. Well, we know that b is 3, so it's going to be 3 squared minus 4 times a. We know a is 1, and then it's going to also be times c, and we know that's 1. And then all of that's going to be over 2a, so it's going to be 2 times 1. And we can work this out, so it's going to be negative 3 plus minus the root, well 3 squared is 9, and negative 4 times 1 is negative 4, and if you multiply that by 1 again, it's still going to be negative 4. So all of that's going to be over, and then 2 times 1 is just 2. And so we can simplify further what's under the square root symbol. 9 minus 4 is 5, and actually I'll just write it out anew. Keep everything explicit, so it's going to be negative 3 plus minus root 5 over 2, and these are our two solutions. By that I mean that one solution is going to be negative 3 plus root 5 over 2, and the other solution is going to be negative 3 minus root 5 over 2. And actually, instead of leaving it in surd form, I'll just write it out for this one example. So we know that our one solution is negative 3 plus root 5 over 2. And we're going to get a decimal value here. I'll just plug it into my calculator really quickly. So it's negative 3 plus root 5 over 2. And that's going to leave us with negative 0.38. Two significant figures. And we also know that our other solution is negative 3 minus root 5 over 2, and that's going to leave us, and again it's going to give us, I think, another negative decimal value. Indeed, we have negative 2.6, and I'm just going to leave that to two significant figures. Okay, and so these are our two solutions, and what they would look like, actually, to make it more explicit or to reflect on the intuition here. This is where these points, these roots, these two solutions, are where our graph is going to cross the x-axis. And we know also from looking at our equation that our graph is going to be an upward facing parabola because the coefficient of the x squared term is positive. And so my best, I'm not going to draw this accurately, but my best sketch is going to look something like this. Okay, and that's this point here is negative 2.6. I'll just define it. That's negative 2.6, and this point here, somewhere in there, is going to be negative 0.38. Right. In any case, let's just carry on. Whoops. Work on another example. Say, I'll think of something different. Say, yeah, this is fine. Say we're given 3x squared plus 10x minus 2. Alright. I'll just rewrite the quadratic formula so it's all very explicit. So negative b plus minus b squared minus 4ac. And then of course all of that is over 2a. So a is going to be 3, or a is 3, b is 10, and c is negative 2. So we're just going to plug these values into our formula, and that's going to give us negative 10, right? Because that's b is 10, and it's going to be negative, so negative 10 plus minus the root of b squared. Well, that's just 10 squared minus 4 times a is 3, times c is negative 2. All that is going to be over 2 times 3, which is a is 3, so 2a, 2 times 3. And so yeah, we can continue to work this out. That's going to be negative 10 plus minus the root. Well, 10 squared is 100, and negative 4 times 3 is negative 12, and then if you're going to multiply that again by negative 2, you're going to actually end up with plus 24. And all of that's going to be 2 times 3 is 6. And so 100 plus 24, that's just going to be 124. And we can actually still simplify this a little bit, in that root 124 is 2 root 31, and I'll just rewrite it down here. Actually, I can write it here maybe. So minus 10 plus minus, this is, oh, actually I don't have enough room there. I'll write it down here. I'll write it right down here. So that's going to be negative 10 plus minus, so root 124 can be simplified to 2 root 31. And all of that's going to be over 6. And now we have a common factor of 2. Everything is divisible by 2. So negative 10 divided by 2 is just going to be negative 5 plus minus. And then 2 divided by 2 is 1. We don't need to write the 1 in front, so it's just going to be negative 5 plus minus root 31. And of course 6 divided by 2 is 3. And so therefore I'm just going to leave it in third form, but therefore our two solutions are negative 5 plus root 31 over 3 and negative 5 minus root 31 over 3. Okay, I'll just leave it in third form. I mean, you can work it out if you wish. And so work on one last example. Again, think of something a little bit different. I mean, there's only so much one can do here. So let's say we're given 11x squared plus 2x minus 7. Okay, all that set to equal 0, of course. And I'll just rewrite the quadratic formula. We know is minus b plus minus the root of b squared minus 4ac. All of that over 2a. Okay, so a is 11, b is 2, and c is negative 7. So we're just going to plug our values into our formula here. And so negative b is going to be negative 2 plus minus the root of b squared. Well, b squared is 2 squared minus 4 times a, which is 11, and then times c, which is negative 7. And then all of that is going to be over 2a, which is 2 times 11. And now we can work this out. So we've got negative 2 plus minus the root. Well, we know that 2 squared is 4, and that's going to, we're going to subtract 4. So it's negative 4 times 11 is negative 44, and negative 44 times negative 7 is going to be a positive. It's going to leave us with plus 308. Okay, could have done that in our on paper here. We could have just written that out, but it's just easier if I save a bit of time if I just work out really quickly. And that's going to be over 2 times 11, which is 22. So we can 4 plus 308 is going to give us 312. So it's negative 2 plus minus the root of 312 over 22. And the root of 312, something awkward, it's going to be 2 root 78. So we can rewrite this as negative 2 plus minus 2 root 78. All of that over 22. And we've got a common factor here in that we can divide everything by 2 basically. And so negative 2 divided by 2 is going to be negative 1 plus minus, and then 2 divided by 2 is just 1. We don't need to write that in front, so it's going to be negative 1 plus minus root 78, and 22 divided by 2 is 11. And so those are our two solutions, and I'll just leave it in third form. So our first solution is negative 1 plus root 78 over 11, and our second solution is negative 1 minus root 78 over 11.